All right, so we're rolling. First CFM Distributors podcast. Man, we've been talking about this for, months and months, and I know I'm super excited about it. I'm here with Elley, one of our sales engineers. And Ty, what do you think, man? You excited?
Yeah, I'm pumped. This is my first time with these headphones on, so super excited. Really want to get the podcast rolling and see if this can turn into something great for us and our customers. So
I'm trying to figure out the echo on here, and hopefully I can live with it as long as you can, even though yours is fake.
Yeah, mine's a prop.
So
One thing at a time.
I've got my list of stuff here because I know since this is the first time I've done this, I'm probably going to forget everything that I want to talk about. But since this is the first podcast, one of the things that we talked about doing is just kind of announcing what we're going to be, what the goal of the podcast is. And we want to keep these relatively short. Obviously, we don't want to be on here for 2 hours, mainly because we have other work to do. We could probably sit here and talk forever, but we like to keep them short, 10 to 20 minutes. And I think one of the things that we talked about that would be fun is to obviously have an HVAC component. That's the whole goal of this, is to educate our customers and to teach the things that we're learning and maybe some mistakes we ran into, but also to have some fun with it too. And one of the topics we're going to talk today about is some stuff on the Chiefs, which we'll get to in a second. So really before we get rolling, one of the things that I know we've talked about recently that we're most excited about right now is our design build module. So if you are listening to this podcast and you're in right now Kansas City or Omaha, and we're rolling this out to our other markets, but essentially we're taking design build topics, bringing value to the customers, maybe talking about the biggest mistakes that we've seen. And the topics we've done so far are on air handlers, water side economizers, and next month is VRF. So anyway,
another goal to it too, just to point out new ways and innovative ways for them to sell more.
Yeah,
as well.
For sure. That's a good point. So the water side economizer one is a lot of fun. There's a cool product out where you can add a set of coils onto the chiller, which is great for the contractor because they get to add a pretty large item to their ticket. But the cool thing is it's great for the business owner too. It saves...
Win-win-win.
It's a win-win-win. I mean, the payback on all those have been very fast, and for an owner, it's a great investment, and they get to save all that money going forward. So anyway, the point of bringing that up is we would love, if you're doing design build work, to reach out to us. We'd love to come by. They take about 20 minutes. We know everyone's super busy. So anyway, that's the intro. So if you're listening to this for the first time, we're going to skip that intro next time. Probably makes sense. And Ty, what did you want to talk about today about the Chiefs?
So this got brought up a little bit earlier. Basically, as the Chiefs dynasty has begun, we have to think about, how are we going to keep all these pieces together? And with Patrick Mahomes being a young guy, hasn't had his big, beefy contract yet.
Yep.
And they're saying his worth in the market is going to be 45, 50 million this year. And do you think it makes sense for him to take a lesser amount, turn down money from the team?
Yep.
And, maybe some kind of creative plan to get different benefits to keep good people around him?
Yeah, and so I went online here this morning and jotted down some notes. Just if any of you are following and don't know the size of his current contract or when it's up, which I wasn't following it super closely, so it was kind of interesting to look up. So Mahomes is just finished his third year of his 4-year contract, which was for a little over 16 million. And ESPN did talk about.
So he's making $4 million a year.
So he's making $4 million a year. And ESPN did mention that they expect the Chiefs to attempt to renew his contract or extend his contract this year and in the offseason. And they expect it to, like you said, be the 40 plus $million a year range, which is, Aaron Rodgers is making 34 million a year.
And I think the salary cap is somewhere like right around 200 million right now. So that would be 25 or 20%. Am I doing that math right? Yeah, 20% of the team's salary cap. And I think I heard on the radio the other day, no quarterback has ever won a Super Bowl at over, could be misquoting this, but it's 17.5% of the team's total salary.
Yeah.
And you have quarterbacks like Peyton Manning and Tom Brady that have taken pay cuts and, you know, allowed their teams to surround themselves with better components.
Yep.
But they also had already played for 10 years by the time they were doing those things.
Sure, and that, you know, if I'm Mahomes and I'm making millions of dollars a year, you know, it's different than if you're making, you know, league minimum at this point. But one of the things that I always think about is almost all NFL players go broke after they retire because, you know, they do make a ton of money, but they also average, I think the average NFL tenure is like 3 or 4 years. So part of it is, you know, if you're Mahomes and you're going to have kids and you've got a family, you want to also be looking out for them too.
Mm-hmm.
And yes, winning multiple Super Bowls would be absolutely amazing if you're Patty Mahomes, but you're also like, you know, I would be thinking about my family. So, you know, having made $16 million, I think I could probably make it work. And I'm not in his shoes, but I would think at this point, if you can.
Which he doesn't have kids yet.
Right, he doesn't have kids yet.
And technically he's not married yet.
And that's okay. That's right.
Is still dating his high school girlfriend.
Yeah. So I don't know. I mean, to me it makes
future
sense.
family.
To me it makes sense since, you know, we catch up quite a bit. That I would go for maybe 15 or 20 million a year. But again, it doesn't seem like that ever happens. He's not that he would be.
Which in our shoes at CFM is nothing too.
Yeah.
I mean, 15, 20 million.
Yeah, it's chump change.
Yeah.
So anyway, so cool. Well, I mean, we'll see what happens. And, you know, obviously it'd be great to keep as many weapons for the 2020 and 21 season and, you know, start winning Super Bowl after Super Bowl.
Yeah.
Exciting stuff.
Personally, I just think too, it's hard to differentiate between 20 and like 30 million. Say you're going to get paid 30 million and we could have a couple really big ads for 20 million. I've said this to people, like, what's the difference between 20 and 30 million? People are like, well, 10 million. It's like, yeah, I get the math, but you're loaded either way.
Yeah.
You know?
For sure. I mean,
there's nothing that you want to do that you can't do. So.
Sure.
Anyway.
Makes sense. All right, so I think that's probably enough on that. Okay, so to the HVAC stuff now, which is the real exciting stuff. So Ty and I are both engineers, so usually this stuff's probably going to get pretty nerdy, and a lot of our other guests are going to be highly technical. So I think this is I think it'll be fun to go through, depending on the week, what topic we talk about, whether it's design related or mistake related or whatever it is. So. I just want to open up to you, Ty, and this week's we kind of left open since it's the first podcast, and want to hear, you know, you discuss maybe one of your favorite recent design build jobs or a mistake that you ran into or anything that you think would add some value here this morning.
Yeah, so I guess I could just talk about a really fun one that I've had recently, and we were trying to get away from refrigeration in a distribution warehouse that they wanted to keep at 60 degrees at certain points of the year. And so, I mean, obviously you're getting in that medium temp refrigeration zone where standard HVAC is starting to cut out and not work and, you know, have problems. So they wanted to get away from refrigeration, and we looked at some rooftop options, standard HVAC, and we're just really kind of nervous about it. So ended up going with the chiller solution and air handlers. And there's definitely been some workarounds with how it's controlled and all of that, but it's turned out to be a really good solution.
Cool.
So just kind of, I guess the point is you can get some really cold box temperatures with chilled water as long as the controls are set up right and you have the correct components in place. So
cool. That's a fun project. I remember working on that, and we went down there a few times, and those are the fun ones for me too, is working on kind of concept to, you know, start up and
cradle to grave.
Cradle to grave.
Yeah.
Exactly. Cool. Well, I had a couple things that I thought would be fun to talk about today. A quick design build story, and then a mistake that I see that happens, can happen somewhat often, and you may not kind of see it coming. And then also kind of an energy code update on a couple things. The energy code update is probably the quickest one. I could start there. So one of the things that I think can be confusing, especially in a major city like this, is there's different In every different city, there's a different code that they follow. So in Kansas City, if you're in Overland Park or Lenexa or Olathe, Shawnee Mission, wherever you're at, it's a different code.
Which we have a pretty cool breakdown of all that too.
We do, yeah. So we built a spreadsheet, an internal tool that we use.
Every time we show somebody, they always point out some city that we don't have on it, but
it's hard to keep updated. But regardless, one of the things that has come up recently, especially with VFDs and modulating fans and such, is a newish code that came out in 2015. It's also in the 2018 Energy Code that a piece of equipment that's got a modulating fan requires 3 stages of cooling if it's between 6.5 and essentially just under 20, and then 20 and above requires 4 stage. And the reason I bring that up is I don't know how often, at least in your
how
market,
many stages of fan do they require?
that's on a modulating fan.
On a modulating fan,
So
okay.
at least the interpretation that I have, and from what I've talked to other design professionals,
Because the code was confusing to me.
the code is confusing, but
Whether
it
they're
does,
talking about specifically stages or the fan. Because I guess, what was that, 20, or was it DOE that required 2-stage cooling above 6.5 tons, or did they require 2-stage fan?
Well, I know it's ASHRAE 90.1 2010
Required 2-stage fan.
Well, it was 2 stages of fan, I believe, and cooling. Yeah, it was 2-stage fans, right?
It was
And
2-stage
10 tons
fan
and
if you
above.
had 2-stage cooling.
That's right.
So basically
So-
you can match the airflow.
So yeah, there's.
Sorry, making it way more
No,
complicated.
you're good. So you got, obviously all the different ASHRAEs and energy codes. But the point is, if your city follows a 15 or 18, in the code it does say modulating fan. So the interpretation that we've had is not if it's staged fan. So most brands have like either what's called a telespeed or a 2-stage fan, where the fan will stage as compressors come on. This is what they call a modulating fan. So our interpretation at this point is if it's controlled as a single zone VAV, or if it's true VAV, then it needs the 3 or 4 stages depending on what size.
Which in telespeed is really designed for a single zone as well.
It is designed for a single zone, that's correct.
It could be changeover bypass,
That's right.
but it's not designed to go to boxes or anything like that.
Correct. Yeah, absolutely. So anyway, thought that was something worth bringing up today. And then the mistake that I want to talk about comes up somewhat often, and essentially what happened on this project is it was for a school, and this was a couple of years back. The designer on the project wanted 2-stage gas heat on these small rooftops, 3, 4, and 5 ton rooftops, which sounds good. I'm all for having more comfort, and it's probably a slight efficiency gain when you're running on first stage because you got a bigger heat exchanger. But the problem comes in on the service and replacement side. So when it's -5 or even 10 degrees outside, and for a school they got kids in there, and all of a sudden the heat is not working for whatever reason. And on this particular job, it needed a new inducer motor, and no one stocks a 2-stage inducer motor on that size of a rooftop. So the school is very upset, and they were upset at us because we provided the equipment. And I still take some fault in not thinking about this ahead of time, is, hey, on a unit that size, maybe we don't go with a 2-stage valve unless we plan on stocking the replacement component. And that's, it's not just the heat, but when you try to take a product and almost over-design it, you almost have to think about what replacement components do the local distributors normally stock.
What are the long-term effects of this?
Right.
And I would like to add to that too, because thinking about that warehouse project that I was just talking about, that was one of the reasons they wanted to get rid of refrigeration or move away from it, is because they were so remote that they didn't have anybody locally that could work on something like that. And so you talk about a school that's in the middle of nowhere, Missouri, the middle of nowhere, Kansas, and you may not have as many specialty people around, and you start throwing modulating this and modulating that and all of these different things that they've never seen before. And then people get really upset when, not to mention, you have to wait to order the part in, and then you can't find anybody to do it, or you're paying from somebody from Kansas City to drive out 2 hours on the weekend, and it starts to get really expensive.
Yeah, no, it's a great lesson to think as a design professional, and it doesn't matter if you're a consulting engineer or you're a PE at wherever, or you're a contractor, or whatever level you're designing the equipment, is it can be fun, especially as an engineer, to get really excited about all the different things you can add, but it is so important to be thinking about what are the goals of the owner and what's going to happen if a piece of equipment goes down. I mean, we see equipment hung in the craziest, highest positions, tucked behind ceiling tiles, and sometimes it has to be that way, but it's always important to think, well, if and when we need to replace this fan motor, what's that going to look like? How are we going to get to it? How fast can we get to it?
It's another great
we
point.
have to tear down and move out.
Is explaining those trade-offs to the owner, and I feel like that is something that is missed a lot, is no one has that conversation with the owner of, hey, 2-stage gas heat, here are the benefits, maybe like 5% of the year, this makes it slightly more comfortable where you're not gonna have as big of a swing in the room. And then they're like, you might find out that they don't care about that at all.
Yeah.
This is for a high school gym,
For sure.
who cares?
Exactly, they just want heat.
Yeah. As long as it's 65 in there, and between 65 and 75, we're good.
For sure.
So,
good point. So the last one that I want to talk about, which, as you know, we do a lot of projects with contractors where we go to a site visit and we help the contractor figure out the load and help them design the equipment layout however they want, and they, with the owner, and figure out how that works. And I actually posted about this on LinkedIn probably last week, how important it is, even on replacing equipment. It's so easy to look at a project and say, hey, we're replacing this 80-ton split system or this 120-ton rooftop or whatever it is, and think, okay, let's just go back like for like, because it makes sense. You don't really want to risk looking stupid or making a big mistake if you say, hey, I think we can get away with a smaller unit, and then what if it doesn't work? So a lot of folks, it intimidates them, but one of the things that we do that I think is a lot of fun, and this project kind of explains it. So Travis, one of our other sales engineers, he was on the road, and Travis, there's a reason why he's not on this podcast. Actually, he's on vacation right now. But anyway, so he emailed me and said, hey, I'm on the road. Can you help do this load calc? And with technology, what's cool is, I can pull up on Google Maps and I can measure the exact square footage of the roof at least take a guess and say, hey, based on the square footage of the roof, you can do street view to see, is it brick, is it block? You have to ask the customer, what's it like on the inside? Is it sheetrock insulation, those sort of things. You get an idea of the windows, are they tinted, and they're a little bit harder to figure out on Google Maps, the size of them. But in this particular job, with all the information that we were working with the contractor, it was a 130-ton existing unit, I can't remember the brand, and just basically quick back of the napkin math, we realized that the load was only about 100 tons. So, and this is a VAV system too, which with load diversity and assuming the whole building is not ever going to be cooling at the same time, we could probably even get away with less. But even if we were conservative and went with a 100-ton unit versus a 130-ton unit, that's more than tens of thousands of dollars saved to the owner. And for a contractor or a distributor or whoever is listening to this podcast and can add this value, it's one thing to go head to head against someone with the same solution and try to go to the thinnest margins as possible. But if you can actually provide this value and say, look, you don't need this much equipment, then you can make it a fair price, a fair margin, and then help the owner save all that money up front.
Yeah, not to mention, to add to that and compile, is that the tendency for people, you see a 130-ton rooftop, then they go to their favorite supplier, they say, hey, we need a 130-ton rooftop. The supplier says, well, we only have 140. And then they're like, well, I guess it's better to go bigger than to go smaller.
Yeah, that's for sure.
So then they end up with a 140-ton rooftop.
Yeah, and then everyone's bidding around a 140-ton rooftop on the job because that's what someone
And
did.
20 years later, the load will be 70 tons in there.
Yeah, and they're going to go back to 150, and all of a sudden now they wonder why they had humidity issues.
Yeah, they're never cooling.
Anyway, that's kind of all I had on my list. Is there anything else?
I would like to add another thing that I'm super excited about. For our design build and job site visits, we have these new toys that we got, and I just got batteries in them yesterday, so we're looking forward to getting out on site and actually using it. But I guess the reason that we got them is we go out on these job sites all the time and there's so many unknowns, and we're like, all right, we're sizing up this equipment and we don't know what the airflow is. It's still running, but we have no idea what the airflow is. We're just guessing. We're like, okay, the ductwork is this big, it serves this many spaces, and here's what we think it is based on the size of the coil.
We've learned guessing is wrong.
Guessing is usually wrong. You could be off by 20, 30% pretty easily.
The frozen coil will tell you that after after a couple of those.
But yeah, so we got a in-duct anemometer, a psychrometer, and a dual port manometer. So we can measure differential static pressures, airflows, drive with wet bulb entering and leaving, and really get a good idea of what's going on, so that we can recommend an even better solution moving forward. So pretty pumped.
I'm excited to use them. I mean, it's one of those things that we ask our customers for that information on jobs they're working on, and for whatever reason, I think a lot of times, our customers just don't have the tools with them, or for whatever reason don't get that. So it's going to be fun to go out and actually take those measurements. And I think, I think our customers are going to like that. I
think we'll learn a lot in the process too, because we'll see and be able to recognize stuff with comparing,
Cool.
Anyway.
Well, I think that's probably a wrap for the first one, you think?
Yeah.
Cool. Well, we'll wrap it up then. Thank you for tuning in today. We'll keep you posted on when the next episode is, and thanks for tuning in. Hopefully it provided value. Let us know. Give us a review and let us know maybe what you liked or what you didn't like. Anything less than 5 stars, I don't know.
Just don't do it.
I don't know how we're going to handle that, if we're going to call them out. No, I'm just kidding. But
we're paying the company, I thought, to take care of people.
Yeah, there's a service that will help take care of all that, which we're looking into. But anyway, seriously, if you can give us a review, let us know seriously what you liked, what you didn't like. What are some topics you want to talk about? I know we talked about the Chiefs and Mahomes for a while, which is probably going to be a common topic, specifically during the season. But if there's anything else too, whether it's a new beer that came out, or Bitcoin, or refinancing your house, or whatever it is, we're here just to have some fun and then talk about some HVAC stuff. So anyway, that's a wrap. And Ty, thanks for joining me, and we'll do it again.
Sounds good.